Good morning, everyone. Welcome back. Thanks for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings, the Science and Technology channel.
Yep, and we're talking about a physics topic today, and superconductors, which anything with super before it or quantum before it, Steve is into. So let's talk about it. Oh, we got quantum too.
I was going to say superconductors are they allow for a large energy transfer of electricity, but these materials they shed a lot of because there's voltage drops, so they shed energy. And when you can get one that sheds a low amount of energy, that's a superconductor, and that's a really good thing to have. All right. Scientists have demonstrated a powerful new way to search for one of physics' biggest prizes, practical superconductors. An international team of researchers has demonstrated a new way to discover superconductors much faster by combining machine learning with advanced quantum physics. The approach allows scientists to sift through an almost limitless number of possible material combinations, we're talking chemical stuff, and pinpoint the most promising candidates for superconductivity. The proof of concept study was recently published in Physical Review Journal on June 17th of this year. Would you like to know more?
Okay, the breakthrough led by the Super-C consortium has already resulted in the discovery of two new superconducting materials. According to Aalto, is that right? Aalto University professor Pavi Torma, who leads the collaboration, the method could significantly accelerate the search for new superconductors.
AI, baby, I'm telling you, AI.
Okay.
Superconductors can carry electricity with zero electrical resistance because of a quantum effect that appears only at extremely low temperatures. That's the key, low temperatures. They are essential for technologies including quantum computers, MRI, and other neuroimaging systems, fusion reactors, and high-speed maglev trains.
Finding new superconductors, however, is extraordinarily difficult. Nearly endless combinations of chemical elements are theoretically possible, but only a tiny fraction exhibit superconductivity. Even those that have already been discovered require expensive cooling systems to reach temperatures close to absolute zero before they can function. Wow.
Researchers around the world are pursuing an even bigger goal, finding a practical superconductor that works at room temperature. Quote, superconductive materials that can operate at room temperature would forever change the way we consume energy, explains Torma. Continuing the quote, if such a material could replace regular conductors in applications like computers and data centers, global energy consumption could be slashed and the heat footprint of the ICT sector vastly reduced.
The Super-C consortium was established in 2023, so not that long ago, by Professor Torma and an international group of leading physicists with the goal of using quantum physics to help address climate change.
Or the effects of the Ice Age.
Okay. It is the first coordinated global collaboration dedicated to discovering new superconductors, and its ambitious objective is to identify a room temperature superconductor by 2033.
We need to watch this carefully to see if it happens. According to Torma, the team's strategy combines quantum geometry with machine learning to dramatically narrow the search. The newly discovered superconductors, and I don't know these chemical names, but we've got some chemical engineers in my ward at church, they would know, known as YRU3B2. I wonder if B stands for boron, and LURU3B2 owe their superconducting behavior to electrons forming flat bands within a Kagome lattice, a geometric arrangement inspired by traditional Japanese basket weaving patterns, of course.
To find these materials, the researchers first used machine learning to screen vast numbers of possible elemental combinations. I'm sure if you were a physicist or a math freak, you'd probably understand all these terms.
You'd be excited about this.
Yeah, giddy. A specialized algorithm identified the most promising candidates, which were then examined using detailed theoretical calculations to determine whether they were likely to become superconductors.
Once those predictions were confirmed, collaborators at Rice University synthesize the materials by chemically combining the required elements into new compounds. The effort was led by Professor Emilia Morosin. Laboratory testing then verified that both materials were indeed superconductors.
The underlying quantum physics behind superconductivity is extremely complex, making the difficult discovery of new materials a slow and difficult process. Quote, over the decades, researchers have recognized over 7,000 superconductors, but mostly serendipitously, explains Torma. Going on with the quote, the process of identifying possible materials is so computationally heavy that, in fact, researchers have only been able to theoretically predict the viability of about 20 of these.
Wow.
Okay.
Even
Wow,
when the
right.
material,
I have no idea what they're talking about. So, wow.
yeah, but so the plausibility for the computational, putting these elements together rather than doing it one at a time in a laboratory, they're using computer models to see what pops up and then they go experiment.
Of course.
Even when a material appears promising on paper, it often proves impractical because it's too difficult to manufacture or impossible to scale for real-world applications. Traditionally, screening enough materials to find useful superconductors has required enormous computing resources.
The Super C team's approach changes that by using machine learning to eliminate unlikely candidates before performing the most demanding calculations. Quote, our method uses machine learning-based pre-screening followed by targeted calculations on the promising candidates. This approach will greatly speed up the superconductor discovery in the future. With machine learning, we may be, would that be AI, right?
Yeah.
We may be able to push the number of materials we can process into the billions. And that's according to Torma. Going on with her quote, I think it's a her, right?
I think so.
Yeah. This will take us a critical step closer to finding a room temperature superconductor.
Super C's research will be featured in Aalto University's Designs for a Cooler Planet exhibition from September 1st through October 30th this year in Greater Helsinki, Finland. So if you're in Helsinki, Finland, check it out.
Yeah, absolutely. And then let us know what you find out.
So what I'm going to do, Scott, is I'm going to take this paper and email it to one of the chemical engineers in my ward and see if he understands, see what he thinks about it.
I was going to say, we changed wards because as soon as you said that, I'm thinking, I don't know of any chemical engineers in our ward.
We've got several because of Dow. Dow's right here.
Gotcha.
I mean, we've got a handful of chemical engineers.
So yeah, they'll get giddy all over this probably.
Yeah.
All right.
All right, folks. Thanks for joining us. Catch you in the afternoon.
See you this afternoon. Thanks for listening.